What's up, everybody? Welcome back to the dirt bike shed. You can see I painted it gray. Yesterday I posted a video on centripetal acceleration, and I deleted it evidently, so I apologize for that. And we're going to come back in here and redo this video. Centripetal acceleration is what we talk about when things are moving in circles. Like, see that piece of tape there? That piece of tape moving in a circle? Now, if you were on a ride at the fair that spun like that, you'd feel sick, right? That's right. So let's talk about that. Centripetal acceleration. Now, here's a video I show a lot in class. And that's these kids. They're in this ride. They're on a ride here, and they used to have this ride at the amusement park beside of my house when I was a kid in Myrtle Beach. It's called the Open Bucket. And you just go in here and you just stand, and nothing's holding you to the wall, and then the room starts spinning. And then eventually it spins fast enough where the floor falls away and you can stick to the floor. I tried to pause it there. My internet's a little bit slow. See, these kids are literally just stuck to the wall because they're spinning. Now, let me ask you a question. If we were going to look at forces involved here, would you say that these kids, would you say that the force in this video is pushing the kids to the outside? Or would you say the actual applied force is pushing these kids to the inside? Well, the answer is the blue arrow. Centripetal force is towards the inside of a circle, okay? And centripetal acceleration means you are going in a circle, or you're going in a circle. I'm just going to write that, okay? Now, let's let these kids go. The reason I'm telling you that the force is towards the center is, yes, these kids are trying to fly away, but the wall keeps pushing them towards the center of the ride. And if the wall didn't push on them, they would fly away. They would fly away in a straight line like this. All right, now we're looking at these two kids from above, and they're on the ride, and the ride is spinning around, okay? Now, if the wall stopped pushing on them at this point, they would just go fly pew, straight away in a straight line. And if you don't believe me, I'm going to show you a little video on that. Now, there's all kinds of videos online of young teenagers spinning themselves too fast on these merry-go-rounds. And what they do is, in most cases, they take a little moped and they put its wheel against the see, there's a little moped back there, and they put its wheel against the ride, and it spins so fast that it just throws people off. It is terrifying when you watch it happen. See, this kid is out of control. Now, these people are all trying to go towards the outside, and when they come off, you'll notice they end up going in a straight line. Centripetal acceleration means going in a circle. Acceleration just means a change in velocity, and velocity is a vector. Velocity is a vector. Now, if you kept changing your vector, you're accelerating. It doesn't mean you're going faster or slower. It just means that you're going in a different direction. Now, if I kept drawing arrows here over and over, and I ended up drawing 360 arrows, what do you think I would have? Yes, I would have, that's right, I would have a circle. A circle is just 360 individual arrows, all right? So let's take a look at this. What if I was a kid on a ride and I was going at, let's say, I don't know, 3 meters per second. That was my velocity, okay? And I'm on a ride, and the radius of that ride is about 1.5 meters, okay? And this is about the size of those little merry-go-rounds we just saw. Well, if that was the case, if I'm sitting on this ride, okay, I'm a kid right there. I'm green because I'm about to throw up. And I'm heading in this direction. Eventually, I'll be heading in this direction. Then I'll be going in that direction. They'll be going that. So I'm accelerating in a circle. And there's a really simple formula. AC equals V squared over R. All right? AC equals V squared over R. What would the acceleration of a kid be? Well, their velocity right here is 3 meters per second. So it's 3 squared over R, 1.5. Bust out my calculator, and I'll say 9 divided by 1.5. They'll be accelerating at 6 meters per second. And I'm going to tell you that that acceleration is lower than what those children are experiencing in the video. All right, so that's simple, correct? Now here's a video of a Ferris wheel. Notice it's much, much larger. But if you think about it, the people on the outside are going faster. They're going faster. Well, there's some little girl for some reason. That's, wow. So I just wanted a shot of this, and now I got the little girl in the video. Anyway, these people are going much faster than the people on the little merry-go-rounds in the video. But since the ride is so much bigger, they're not going to feel like they're accelerating as much because their radius of the circle is so much bigger. So let's take a look at a problem like that. What if we had a Ferris wheel and it was very, very large, okay? Let's say it's got I know that's a terrible circle. I know, you're laughing. It's okay. Let's say it's got a 12-meter radius. And they're going out here going much faster. Let's say they were going twice as fast as the other kids. Let's say they're going 6 meters per second. Which would be a little fast for a Ferris wheel, but hey, I'm just making a point. AC equals V squared over R. The centripetal acceleration on that Ferris wheel would be 36 over 12, or 3 meters per second. So that shows you, 3 meters per second, that not only is your velocity important, but the radius is also super, super important, right? And I didn't make that line, but hey, we'll take it. Now let's go back to the wheel, okay? Here I am, I'm spinning the wheel. I want you to look at that piece of tape going around in a circle. Now, if you were riding this wheel and you were an ant, you'd be feeling pretty sick, okay? Now, there's a couple of things I'm going to ask you because we're talking about things moving in a circle. First, let's think about this circle. What is the distance around a circle called? It's called the circumference. And the circumference is equal to 2 times pi times the radius. Now, I've measured the radius of this bicycle, and the radius of this bicycle wheel is 0.23 meters. And I can show you here if you don't believe me. I don't know why you call your chemistry teacher a liar, but it's physics teacher a liar, but it's 0.23 meters. So here's a question I've got for you, and it's going to be, it's going to take some thinking. If the circumference is equal to 2 pi r, and I spin this thing this fast, okay? Speed up. All right, now I'm spinning it right now, and I'm counting the revolutions. And this thing's going to spin around 10 times in 7 seconds. What I would like for you to tell me are 2 things. 1, what is the velocity of that piece of tape? And 2, what is the centripetal acceleration of that piece of tape? All right, I'm going to give you a hint. All right, here's a little picture of the wheel. I'm telling you that this wheel makes 10 revolutions in 7 seconds, okay? Now, first you're going to need to use C equals 2 pi r, and you're going to need to use that as the distance that the piece of tape travels, okay? So if this piece of tape goes around a circle, if we cut that circle and laid it out straight, it's just a straight line, right? So C equals 2 pi r is that distance. Then you can use velocity is equal to distance over time, right? To find out the velocity right here of the piece of tape, okay? Secondly, I want you to tell me the acceleration of that piece of tape using v squared over r. We know that 0.23, that's the r, and the velocity is going to be the velocity that you just solved for right here, okay? So the circumference, 2 pi r, is going to be the distance using this formula, okay? So 10 revolutions would be what distance? And it will go that distance in 7 seconds, right? So velocity equals distance over time. Then you're going to put that velocity right here, and you're going to tell me the centripetal acceleration of that piece of tape as it goes around and around and around and around and around. The last question I'm going to ask you is this. That's your homework, okay? This is your homework. And that's question number 1. That's question number 2. And question number 3 would be, if the tape flew off at this green mark as it's going around the circle, what direction would the tape go? And that's going to be number 3. What direction? All right, I'm going to repost this, and I'm sorry I accidentally deleted the video from yesterday. Good luck, people. Peace out from the Dirt Bike Shed.